Have you ever wondered about the biggest, strangest things in space? Let's talk about one of the most mysterious objects out there, a black hole. Imagine you have a really, really heavy bowling ball. Now imagine squishing that bowling ball until it's smaller than a tiny marble. Even though it's tiny, it still has the same mass as the big bowling ball. That makes it incredibly dense. A black hole is like that, but on a cosmic scale. A massive star collapses in on itself, squeezing an unbelievable amount of matter into an impossibly tiny space. It's so dense, its gravity becomes insanely powerful. That super strong gravity is what makes a black hole so special. Gravity keeps you on the ground and keeps the Earth orbiting the sun. But a black hole's gravity is so intense nothing can escape once it gets too close. Think about throwing a ball up in the air. It comes back down because of Earth's gravity. If you could throw it fast enough, escape velocity, it would fly off into space. For a black hole, escape velocity exceeds the speed of light, and light is the fastest thing in the universe. Since not even light can escape, the black hole appears completely black. How does one form? It starts with a giant star, much, much bigger than our sun. When these stars run out of fuel, they can't support their weight. The core collapses in a supernova explosion. The explosion blasts outer layers into space while the core keeps collapsing inward. Now for the big, exciting question. Could a black hole ever just wander into our solar system for a visit? The idea sounds like something straight out of a science fiction movie, doesn't it? Well, scientists have thought about this, and the short answer is, incredibly, astronomically unlikely. Space is, to put it mildly, gigantic. Distances between stars and objects are vast, almost impossible to truly imagine. Our solar system is like a tiny grain of sand on an infinitely large beach. For a rogue black hole to travel through the emptiness of space and happen to stumble right into our little neighborhood would take an almost unbelievable stroke of bad luck. Most black holes we know are safely located, either at the centers of galaxies, like the supermassive black hole at the heart of the Milky Way, Sagittarius A, or as remnants of massive stars inside the galaxy. These black holes are in stable orbits, moving with everything else. But rogue black holes could exist. They might be ejected from their homes, maybe by a powerful supernova or by gravitational interactions with other massive objects. They'd wander the galaxy, completely dark, nearly impossible to detect unless they passed in front of a distant star, bending that star's light. Even if millions roam the Milky Way, the chances of one coming near us are vanishingly small. The galaxy is enormous, about 100,000 light-years across. A light-year is how far light travels in a year, which is roughly 6 trillion miles. Our nearest star, Proxima Centauri, is over 4 light-years away. For a wandering black hole to cross those distances and find our tiny corner of the galaxy is less likely than winning the lottery every day for the rest of your life. It's a fun, scary thought experiment, but not something astronomers worry about. The probability is so low it's practically zero. We live in a quiet, stable arm of the Milky Way. This isn't a crowded, chaotic region where such events are common. Scientists are mapping nearby stars and motions, and there's absolutely no evidence of a black hole headed our way. We are safe from these cosmic wanderers. But what if we weren't? What if one did pay us a visit? Let's use our imaginations and say the impossible happens. A stellar mass black hole, maybe a few times heavier than our sun, enters the outer edges of our solar system. We wouldn't see it coming, of course, because it's black. The first sign would be its gravity. Long before it got anywhere near the inner planets, its immense gravitational pull would start to disrupt the orbits of objects in the Oort cloud. The Oort cloud is a giant spherical shell of icy comets far beyond Pluto. The black hole's gravity would act like a giant stick stirring a hornet's nest, sending a shower of comets hurtling toward the inner solar system, including toward Earth. As the black hole moved closer, past the orbit of Neptune, past the orbit of Uranus, things would get even more chaotic. The careful balance of our solar system, which has been stable for billions of years, would be completely shattered. Planets are held in their orbits by the sun's gravity. But if an object with even more gravity came along, it would become the new boss. Jupiter, Saturn, Uranus, Neptune would be pulled from their familiar paths. They could be flung out of the solar system entirely, or pulled into new chaotic orbits around the black hole itself. The asteroid belt, located between Mars and Jupiter, would also be thrown into disarray, scattered like marbles. Many asteroids would be sent flying in all directions. Some would be catapulted out into deep space. Others would be pulled inward, creating a deadly cosmic pinball machine in the inner solar system. The risk of a major asteroid impact on Earth or the other inner planets would increase dramatically. The sky would be filled with more shooting stars than ever before. But some of these would be civilization-ending asteroids heading our way. The beautiful, predictable clockwork of our solar system would become a storm of gravitational chaos. The sun itself would feel the effects. Our star is the anchor of our solar system, but it would be no match for the gravity of a black hole, even a small one. The sun and the black hole would begin to orbit each other in a frantic dance. This would pull the sun from its position at the center of the solar system, dragging all the remaining planets along with it. The shape of our orbit would change drastically, leading to extreme temperature swings on Earth. We might be pulled much closer to the sun, boiling our oceans, or thrown much farther away, plunging our world into a permanent deep freeze. The moon's orbit around the Earth is a delicate balance. The black hole's gravity would tug on the moon, pulling the moon away from Earth, or sending it on a collision course with Earth. The gravitational pull would also cause unimaginable tides on Earth. Forget high and low tide. Tidal waves miles high scouring the continents, washing over entire cities, a global tsunami. If the black hole passed close to Earth, within the orbit of the moon, the direct gravitational forces on the planet would be catastrophic. The side facing the black hole would be pulled much more strongly than the far side. This stretching force is called a tidal force. It's the same force that causes ocean tides, but scaled up to an unimaginable degree. The planet's crust would crack and buckle, massive earthquakes would trigger, volcanic eruptions would follow. The ground would be torn apart, the planet would stretch. Scientists call this spaghettification. So, sleep soundly tonight. Our solar system will remain black hole free, where we can safely look up at the stars and wonder, without worrying about one of those mysteries visiting us for dinner.